Agricultural systems are a major source of greenhouse gases to the atmosphere, contributing to global climate change. Society now faces the major challenge of providing food for a growing world population while mitigating these emissions to avoid future climate catastrophe. Our SMARTFARM team is taking unprecedented measurements of soil carbon dioxide and nitrous oxide emissions from an agricultural field in central Illinois so that we can improve our ability to predict how climate-smart agricultural practices will affect these emissions.
We're about to head to Node 1. That's one of the locations in this field where we have a bunch of gas flux chambers and other equipment. We come out here about once a week to collect a variety of soil environmental data to be able to complement the greenhouse gas emission data that we collect. There are a variety of different properties in the soil that kind of govern the emissions of both N2O and other greenhouse gases. This is the deep soil moisture access probe, and what we're going to be doing is measuring soil moisture. We're going to plunge this probe down into the ground to measure how wet the soil is. The different depths of the soil all have microbes living in them, and those microbes are producing and consuming nitrous oxide. So that's why we're really interested in measuring soil moisture to complement this gas flux data. Here we are at one of our gas flux chambers. The lid of this chamber, once an hour, every hour, will close, and it will collect gas inside of this chamber right here. The gas that we're collecting is both carbon dioxide and nitrous oxide, and those are greenhouse gases that we're interested in measuring from this site. Our lab is especially interested in understanding the dynamics that govern N2O emissions from these agricultural systems, because N2O is both a really potent greenhouse gas. It has a warming potential approximately 300 times greater than carbon dioxide on a per molecule basis, and it's a really key player in terms of the greenhouse gases that come out of agricultural systems specifically. Here we are at the center of one of our nodes, and what we have are these dog houses to contain all of the instruments that we use to basically collect the data for the various things that we measure at this site. We're also measuring soil oxygen content and soil temperature, and all of those things, again, are being measured once an hour all year round. And so we have these, workhorse instruments that we bring out here in the spring and install them in the site, and we can actually look at it remotely from on campus or really anywhere in the world. So we have a Wi-Fi tower set up so that we can get the data stream from anywhere we need to.
To complement the field measurements that we've been making of the soil greenhouse gas emissions and soil moisture and temperature, we've also taken soil cores to the lab to do extractions to look at how much ammonium and nitrate substrates, how much organic carbon is there. We're really excited to be finally at the point where we have a lot of field data as well as lab data where we're able to overturn our current paradigm of the controls on nitrous oxide production in agricultural soils. We've been moving our measurements to different fields year to year so that we can understand how the controls on soil nitrous oxide emissions can vary depending on soil type. We're actually upcoming going to move our equipment back to the first field that we worked in so that we can also look at interannual variability in weather and how differences in soil moisture and precipitation can also change these controls.